Hello students, in this session we will see the reflection loss and reflection factor. We know that the electrical lines which are used to transmit the electrical waves along them are called transmission line. We know the primary constants, so RL, CG, so resistor, capacitors, inductance and conductance. So then secondary constant also Z0 and gamma, so characteristic impedance and propagation constants, we already know that. So in this, the transmission line, the load impedance ZL or receiver impedance ZR is equal to the characteristic impedance Z0. That is, the transmission line is terminated with Z0, then there is no reflection and all. Then whatever we supply the energy from the source, it will be completely delivered to the load. Then the transmission line, the load impedance ZL or receiver impedance ZR is not equal to the characteristic impedance. That means the line is not properly terminated with the characteristic impedance Z0. Then mismatch occurs. Then part of the energy is rejected and reflected by the load to the source. So here the load is not absorbed full energy, whatever we supplied or we transmitted to the receiver. So part of the energy will be reflected towards the source. So the energy delivered to the load under mismatched condition is less than the energy delivered to the load under perfect matched condition. So this loss is called reflection loss or mismatch loss. So here in this circuit, if you see, the ES is the input source voltage and ER receiver voltage, IS input current, IR output received current. So L is the length of the line, then P2, P1, P3. So here P1 is power at the receiving end due to the incident wave. So power is at the receiving end due to the incident wave, because we are transmitting that signal, then it will be reaching receiver. That power is called P1. Then P2 is power absorbed by the load. So power absorbed by the load. Then P3 is power reflected back down with the line. So P3 is the power reflected back to the source. So here the current I2 dash is the load current under image matched condition. If you imagine the matching condition, that is the terminated line is terminated with the characteristic impedance Z0, then I2 is the actual load current under image mismatch condition. So here the reflection loss is defined as the number of amperes or decibels by which the current in the load under image mismatch condition, that is under image matched condition, would exceed the current actually flowing in the load. So the reflection loss in amperes is given by reflection loss equal to ln I2 dash by I2 amperes. So if you take in dBs, 20 logarithmic of I2 dash by I2 into dB. So here I2 dash is the load current under image matched condition. If you think it is matched condition, then it is the I2 dash. So it is normal, actually current is I2. So here reflection loss is called the mismatch loss. So the ratio between I2 dash and I2, that is matched current and mismatched current, is called the reflection loss. So reflection loss in terms of power, so power P equal to I square. So here current I equal to square root of P. Then the reflection loss, if you substitute the values I2 dash by I2, so I2 dash is P1 square root I2 dash. So here I2 is the P2 1 by 2, because I2 is the is equal to P1. Why means P1 is the incident power due to the source at the load. So if we think it is matched condition, means the complete power whatever we transmitted, it will be absorbed by the load or receiver. So if it is the current, that time current is called I2 dash. So we are taking P1. Here in I2 it is the actual, because actual power is absorbed by load is called P2 only. So actual current is I2. So here instead of I2 we are taking P2. So we are comparing P1 and P2, then square root of P1 and square root of P2. Here P equal to I square, that is P proportional to I square. So I equal to square root of P. So here if you substitute the value square root of P1 and square root of P2, then common square root if you take P1 by P2, so 20 logarithmic P1 by P2 square root. So that too it will come down, then multiply with 20, then it will gives 10 logarithmic P1 by P2 in dB. So if it is equal to reflection loss normally 20 logarithmic into 1 by tau. So here tau is the reflection coefficient. So that formula is ZL minus Z0 by ZL plus Z0 or ZR minus Z0 by ZR plus Z0. So here the voltage and current at the receiving end due to the reflected wave are tau into ER and tau into IR, because that voltage is multiplied with the reflection coefficient, current multiplied with the reflection coefficient. So here P1 is the power, received power at the receiver. So ER into IR, normally E into I, P equal to E into I. So that formula. So P2 is power absorbed by the load. P2 is the power absorbed by the load. P3 is the reflected power. So in the circuit, I already explained. So P1 and P2 is absorbing, balance P3 is reflecting. So here, so what is the absorbed power means whatever we transmitted, then whatever it is reflected by the load. So that difference is called difference only the power absorption. So here P2 is the power absorbed by the load, which is equal to whatever we transmitted P1 and whatever it is reflected by the load P3. So the difference between P1 and P3, so P1 minus P3 is called P2. Okay. So here the reflected power, if you take, so in terms of reflection coefficient, the reflected current and reflected voltages are tau ER and tau IR. So reflected voltage and reflected current, tau into ER and tau into IR. If you multiply these two, then tau square into P1, ER into IR is P1. Okay. So here if you substitute this one, P2 equal to P1 minus tau square P1. If you take common P1, so 1 minus tau square, the reflection loss equal to 10 logarithmic of P1 by P2. So here, so if you substitute this value in P2, here P2 equal to 1 minus tau square into P1. If you substitute this value, P1 will get cancelled. So 1 by 1 minus tau square dB. So already we know that tau is the reflection coefficient. So formula is ZR minus Z0 by ZR plus Z0. Okay. So if you take this term 1 by 1 minus tau square term, so here 1 by 1 minus that tau only we are substituting the equation ZR minus Z0 by ZR plus Z0 whole square. Then if you multiply 1 with ZR plus Z0 whole square, then the balance will by ZR plus Z0 will goes up. Here ZR plus Z0 square minus ZR minus Z0 square. Here if you apply the A plus B whole square, which is equal to A square plus B square plus 2AB. Here A minus B whole square, here A square plus B square minus 2AB. So here ZR square plus Z0 square plus 2AB and minus of ZR square plus Z0 square minus 2AB. So if you take here minus, then ZR square term will become minus, Z0 square term will become minus. So here it is plus, here it is plus ZR square plus Z0 square. So here plus and minus will get cancelled. So ZR square will go off, Z0 square will go off. Here 2 Z0 ZR will be there. Then again here minus of 2 ZR Z0 is there. So here 1 minus, inside one bracket 1 minus, so minus into minus plus. So here 2 ZR Z0 plus 2 ZR Z0. So totally 4 ZR Z0. So the equation 1 by 1 minus tau square equation will become ZR plus Z0 whole square divided by 4 into ZR Z0. So here this equation. So here reflection loss then by 10 logarithmic of that value, that is 1 minus tau square. This is the formula, this is the equation we obtained here. So ZR plus Z0 whole square divided by 4 into ZR Z0 in dB. So here if you take common square, then 4 will become 2, then here ZR Z0 if you take root, then total square will come up, because 4 means if you 2 square 4, then square root means it will become normal. Then if you 2 will come down 20 logarithmic, here 10 log to ZR plus Z0 by 2 into square root of ZR Z0 whole square. So here these two will come down and multiply with 10, it will becomes 20 log of ZR plus Z0 by 2 into square root of ZR Z0. So if you say this one 20 logarithmic of 1 by k, so k is the values ZR plus Z0 by 2 into square root of ZR Z0. So reverse. So 1 by k it will becomes. So actual k, how much it will come? This 2 square root of ZR Z0 will go up, and balance from ZR plus Z0 will come down. So k equal to 2 into square root of ZR Z0 by ZR plus Z0 is the reflection factor. So is the reflection factor. This ratio indicates, this reflection factor in ratio indicates the change in current in the load due to the reflection at the mismatched junction, and is called the reflection factor. Thank you.